Hello, everyone. In this video, we will be talking about Chandrayaan 3 mission. So, let's get started. Back in October 2008, India launched a mission called Chandrayaan 1. This mission was sent to the moon. And guess what? It discovered something super exciting that got everyone talking all around the world: water on the moon. This was a big deal because it was the first time we had really strong proof that water exists on the moon. This water was found in a place called the South Pole area of the moon. After this cool discovery, lots of countries got really interested in exploring the moon again. The USA and China started sending missions to the moon regularly. Even Israel tried to gently land something on the moon. And countries like Japan, Europe, and Russia had plans to do more missions to the moon. Missions to the moon come in about 5 to 6 different types, each with its own purpose. These missions began in the 1950s and have become more complex as technology advanced. The simplest kind of mission is a flyby. This involves sending a spacecraft to space that goes close to the moon but doesn't orbit it. It just passes by and continues on its way. The first successful flyby was done by the Soviet Union in January 1959 with their spacecraft Luna 1. 2 months later, in March 1959, the United States achieved its first successful flyby with a mission called Pioneer 4. The initial goal of these missions was to study the moon from a distance. In October 1959, the Soviet Union launched Luna 3, giving us our first close-up photo of the moon. This image captured the mysterious side of the moon that we don't usually see from Earth. Nowadays, flyby missions are typically undertaken when a spacecraft is en route to another mission, rather than being the main objective. However, when in-depth examination of the moon is the aim, the next kind of mission comes into play: the orbiter missions. These spacecraft get close to the moon and start circling it, a phase called lunar orbit. This allows for detailed studies of the moon's surface and atmosphere. Over 40 successful orbiter missions have been carried out so far, making this the most common type of moon mission. The first successful orbiter mission, once again, was accomplished by the Soviet Union with Luna 10 in 1966. The next kind of mission is known as impact missions, which is an extension of orbiter missions. In these missions, the main spacecraft keeps orbiting the moon while a part of it breaks away and intentionally crash lands on the lunar surface. The term impact refers to this controlled crash landing. You might be wondering why crash land something on purpose. Well, it turns out that during the time leading up to the crash, when the detached part is descending towards the moon's surface, scientists can gather a lot of valuable data from various instruments on board. That's why impact missions are quite valuable. Chandrayaan 1, the Indian lunar mission, was an example of an impact mission. In Chandrayaan 1, the separated portion that crash-landed on the moon was called the Moon Impact Probe. This probe carried an instrument called Chandra's Altitudinal Composition Explorer, or CHASE for short, which helped gather important information about the moon. Chandrayaan 1's Moon Impact Probe had a mass spectrometer that took readings every 4 seconds as it descended for its crash landing. This helped discover water in the moon's atmosphere. The probe landed in the Shackleton crater, with the point of impact named Jawahar Point. Chandrayaan 1 also had an independent orbiter. The Moon Impact Probe was launched with the orbiter, and NASA's Moon Mineralogy Mapper (M3) instrument was aboard this orbiter. The crash of the Moon Impact Probe caused lunar soil to fly up. M3 analyzed this soil and confirmed the presence of water in the moon's soil. The fourth category of moon missions is lander missions. These missions involve sending a part of the spacecraft to the moon with the goal of achieving a soft landing. The part that lands is known as the lander. This process is incredibly complex and challenging. The initial attempts by both the US and the Soviet Union to land softly on the moon were met with failure in the first 15 tries. This shows how difficult it was. In 1966, the Soviet Union succeeded in their Luna 9 mission. It marked the world's first successful soft landing on the moon. This mission not only achieved a landing but also captured the moon's surface in a photo. Though the quality of the image isn't very high due to the technology available at that time. Lander missions usually involve bulky and heavy spacecraft that land on the moon's surface and stay put, without moving around. For more mobility on the moon, the rover missions were developed. Rovers are small robots with wheels that can move beyond the lander, allowing for exploration. They enable direct interaction with the lunar surface. The first successful rover was sent by the Soviet Union in November 1970. The final category is human missions, where astronauts are sent to the moon. They land in a lander and, instead of a rover, they walk on the moon's surface. The United States achieved this historic feat in 1969, when Neil Armstrong became the first person to step onto the moon. After NASA's last human moon mission in 1972, no one has returned to the moon, making a total of only 12 people who have walked on its surface, all from NASA. These are the 12 people. On September 6, 2019, during the planned soft landing of Chandrayaan-2's Vikram lander, an unexpected crash occurred. The Failure Committee report, disclosed in November 2019, attributed this accident to a software error. However, ISRO did not release this report publicly, which was surprising given their prior transparency about mission outcomes. This lack of transparency marked a departure from ISRO's usual practice of openly sharing mission updates, both successes and failures. Initially, ISRO indicated that the lander was intact and resting tilted on the moon's surface, which led to criticism due to conflicting information. Eventually, on January 1, 2020, ISRO's chief confirmed that the lander had, in fact, crashed and was destroyed. Data displayed at ISRO's Mission Control Center indicated that the Vikram lander deviated from its intended path when it was about 2 kilometers above the lunar surface. Contact was lost at an altitude of about 335 meters. When the Vikram lander of Chandrayaan-2 was descending to land, it had trouble slowing down. It was supposed to take pictures to pick a safe spot, but couldn't because it was unstable. One of its engines had too much power, making it wobble. Vikram tried to fix its position, but its thrusters were misaligned, causing it to spin. The spinning got too fast due to the software's limits, and it ended up crashing. Chandrayaan-3 is India's new attempt to do what Chandrayaan-2 couldn't do. They've made changes to avoid past mistakes. Chandrayaan-3 can land in a much larger space, about 40 times bigger than before. The Vikram lander in Chandrayaan-3 has extra fuel to stay above the moon's surface longer to pick the right spot. The software of Vikram has been upgraded, so it can spin faster if needed. Improved landing. This time, Vikram won't rely only on pictures to land. Chandrayaan-2 had mixed results. While the landing didn't go as planned, the orbiter it sent is still working and orbiting the moon even now. Chandrayaan-3 is using high-quality pictures from Chandrayaan-2 to pick better landing spots. The new Vikram lander is quite similar to the old one, but with improvements like stronger legs, more solar cells, and better sensors. Just like Chandrayaan-2, the main goal of Chandrayaan-3 is still to land near the moon's south pole and deploy a rover. The landing area is at 70 degrees south and has lots of craters that are always in the dark. When Chandrayaan-3 sets the rover on the moon, it will have only one lunar day to do its science. A lunar day is about a month on Earth, with 2 weeks of light and 2 weeks of darkness. Pragyan will have just 14 days to collect data because it can't function during the freezing lunar nights, which can get as cold as -232 degrees Celsius. So, they want to land when the sun is rising on the moon, giving them sunlight for about 14 to 15 days to work. If they can't land in August, they'll wait for September. The Vikram lander weighs 1,750 kilograms, and the rover, Pragyan, weighs 26 kilograms. Their goal is to land near the moon's south pole to explore the area's mysteries. Chandrayaan-3 consists of 3 modules. Lander module. This carries the Vikram lander. which will make a gentle landing on the moon. Rover module. This holds the Pragyan rover, which will explore the lunar surface. Propulsion module. This is responsible for moving Chandrayaan from Earth's orbit to the moon. It will place the lander and rover into lunar orbit, and when they're about 100 kilometers from the moon's surface, it will release them for landing. This module will also stay in the moon's orbit for 3 to 6 months. It will assist with communication, data collection, and more. It has an instrument called SHAPE, spectropolarimetry of habitable planet Earth. Since Chandrayaan-2's orbiter is still operational, it will be used for this mission, and hence, there's no separate orbiter module in Chandrayaan-3. The Chandrayaan-3 mission has an instrument on the propulsion module called SHAPE, which will search for small exoplanets in space. Pragyan rover have fascinating instruments. Pragyan rover. It has 2 instruments, LIBS and APXS, LIBS, short for laser-induced breakdown spectroscope. It checks the moon's soil for different minerals. APXS, alpha particle X-ray spectrometer, which does the same but for moon's rocks. While Pragyan is using these instruments, Vikram lander will be busy taking photos. Vikram lander has 4 instruments on it. Remember, the full name is Radioanatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere. It aims to melt small lunar stones with a laser and study the gases released from them. CHASTE stands for Chandra's Surface Thermophysical Experiment. It measures the temperature and thermal properties of the moon's south pole. ILSA. This stands for Instrument for Lunar Seismic Activity. It's like a moonquake detector, measuring seismic activity on the moon. This helps understand the moon's crust and mantle structure. LRA, Laser Retroreflector Array. It uses lasers to bounce signals off the Earth, helping scientists calculate the precise landing location of the Vikram lander and the moon's range. There are already 5 retroreflectors on the moon, and Chandrayaan-3 will add another. Chandrayaan-3 has a total of 7 instruments, which are also referred to as payloads. This term is often used for scientific equipment on spacecraft. Beyond scientific discoveries, this mission carries a sense of national pride. If successful, India will become the 4th country, following the Soviet Union, the USA, and China, to achieve a soft landing on the moon. This was intended in 2019 with Chandrayaan-2, but the landing part failed. Chandrayaan-1's impact mission previously made India the 5th country to touch the moon's surface, after the Soviet Union, the USA, Japan, and Europe. Since then, 4 more countries have accomplished lunar landings: China, Israel, Luxembourg, and the United Arab Emirates. Countries like China, Israel, Luxembourg, and the United Arab Emirates achieved lunar landings in 2009, 2019, March 2022, and December 2022 respectively. India's next major venture is the Gaganyaan mission, which aims to send Indian astronauts into orbit. Originally planned for 2022, it's now expected in 2025 due to delays. Recently, Russia's Luna 25 mission to the moon has failed. The spacecraft crashed upon landing. The United States Artemis II mission is scheduled for November 2024. It will send astronauts to orbit the moon, marking a significant journey into deep space. Looking ahead, China is also planning to send astronauts to the moon in the coming years.